Okay, well, welcome everybody, and thanks for attending today's webinar, Fuel Management Analysis and Reporting Best Practices with AssetWorks and Mercury Associates. My name is Grace Delvecchio, and I'll be moderating today's presentation. We'll be getting started in just a moment, but first, I'd like to say how excited we are to have our presenters with us today, Michael Terreri and Tracy Spann from AssetWorks, along with Daniel Reichman and Brian Franklin from Mercury Associates. Before I pass things over to our presenters, I just wanted to give everybody a quick heads up. The microphones have been muted, so if any of you have any questions at any time during the presentation, you can use the WebEx chat tool. You should all see the chat icon located on your screen, and this acts as an instant messaging tool. Please feel free to use the WebEx chat tool to enter any questions you may have throughout today's webinar. Make sure you send all questions to the host, and I'll be happy to field and relay them to our presenters at the conclusion of the presentation for a brief Q&A session. So with that said, I think we're ready to get started here. Daniel, I can see your screen and you are good to start.
Thank you, Grace, and welcome everybody. Good morning or good afternoon. You can hear me, right?
Yes, we can.
Great. So again, my name is Dan Reichman. I am the Director of Advisory Services for Mercury Associates. I've been with Mercury for 3 years. Mercury Associates, for those who don't know, is a fleet management consultancy, the largest dedicated fleet management consultancy in the country. We've been in business for almost 25 years, of which I've only been with the company for 3. My background in fleet management is with 20 years of federal government service, managing the leased portion of the federal fleet, which is quite large in terms of asset count, about 225,000 vehicles, not as diverse as many public utility municipal fleets, but it has a quality in quantity of its own. With me is Brian Franklin. He's a manager with Mercury. He joined us as a full-time employee last summer, and we welcome his inclusion onto the team. He has over 31 years of experience working in municipal government with the city of Tulsa, of which 14 was directly as one of 2 city fleet managers overseeing the city's fleet. He is a CAFM certified fleet manager, as well as an APWA certified fleet public professional. The topics that we will be covering today include high-level look at fueling KPIs, the key performance indicators, touching on how to forecast fuel, the impact of fuel on chargeback rates, some metrics on tracking fuel, discussion of idle time aspects, and then we'll touch on EV charging and what you can do with information captured us there, the EVs that you may have issues. With that, I'm going to turn it over to Brian.
Okay, thanks, Dan. Again, good afternoon, everyone. Can everyone hear me okay?
Yep.
Yep, go ahead and forward to the next slide. This slide just provides an overview of some of the KPIs that we'll be discussing today. So go ahead and move to the next. Okay, so the first item that I want to talk about is the importance of using FMIS data to forecast fuel consumption and cost. As indicated on the screen, it's important to developing budgets, forecasting future expenses, analyzing past consumption patterns and price trends, and optimizing fuel purchasing strategies. In my previous position as a fleet manager, we were responsible for purchasing over 2 million gallons of fuel each year for 7 fuel stations. And we relied upon FMIS data to identify how much fuel was needed at each station on a daily and monthly basis, and also to identify how much fuel each department needed. Some of our departments were more focused on using vehicles that took unleaded fuel, but others were more evenly, they used vehicles that used both diesel and unleaded consumption. We also relied on FMIS data to develop fuel budgets for our customers to make sure they had adequate funds appropriated to cover their fuel cost for the upcoming year. In the chart on the right side, this is just an example of forecasting fuel consumption for FY25. You'll see on the blue and red lines, the unleaded fuel consumption is tracking downward from year to year, while diesel fuel consumption is increasing year to year. So again, this is just an example of looking at fueling patterns and then projecting fuel consumption for future years. So next slide. In this example, it's important to use FMIS fueling data to, in this example, to extrapolate what our gallons will be for FY25 and then what our fuel cost will be. So on the left side is consumption. So for FYs 23 and 24, actual consumption was around 1.2 million gallons. And for FY25 year to date, it was around $700,000. So again, looking at previous fiscal years and then how you're currently tracking, then you can extrapolate your projected consumption at the end of FY25. The FY26 column in this example is basically developing a budget based on a 3-year average of fuel consumption for the previous 3 years. So again, this is just one example of how data can be used to forecast future consumption. And then on the cost side, again, using the same methodology to extrapolate FY25 cost and then the FY26 projected budget, again, using a 3-year average of previous fiscal years. So next slide. I know at the City of Tulsa, we developed chargeback rates to cover our direct and indirect cost, and then we build that to departments. So this is just an example of looking at your annual fuel gallons. So in this case, it's about 1.2 million. Then your direct cost, which represents your fuel cost of a little over 4 million. And then your indirect cost, which represents all your personnel and operating cost used to maintain your fueling operation. So you add those together, come up with a total cost, and then you develop a chargeback rate and a markup to make sure that you're recouping all your cost. So in this example, this organization would need to charge their customer or department $3.26 per gallon to recover their direct and indirect cost, and $3.70 a gallon to recover their diesel cost. Next slide. Here's an example of a KPI used to track an organization's progress in meeting reduction goals for fuel and emissions. So in this KPI example, there are 2 different KPI goals. One is to reduce unleaded fuel consumption by 10%. The second is to reduce carbon emissions. And in the description column, it just identifies the time period for the KPI, which is from January through December. And the goal is to reduce unleaded consumption by 70,000 gallons and reduce carbon emissions by 1,000 tons. And then the last 2 columns, the KPI target, that represents your targeted goals. And then the KPI results is at the end of the year. You report if you achieved or underachieved in attaining your goal. So again, this is a 1-year KPI goal. So it's really important to monthly monitor your progress and meeting your target, so that at the end of the year, you can better meet that goal. Next slide. FMIS is important to track your fuel consumption rates, to evaluate the fuel efficiency of your vehicles, to identify vehicles with poor MPGs, to determine if they need to be fixed or replaced, to determine whether high consumption is due to poor driving habits, and then identifying whether similar units are consuming similar amounts of fuel. So in the table on the right, this is an example, looks at 4 similar vehicles, 2011 Ford F-150, and then you'll look at the last column, which is the miles per gallon. So the top 3 units are within an acceptable range for MPGs from 11.1 to 15.5, but the last unit is achieving a poor MPG of 4.5. So this vehicle would need to be investigated to understand why it's below the other units. Next slide. FMIS data is important to track your average gallons per transaction in order to understand driver fueling patterns, determine if employees are acquiring more fuel than what's required for their job duties, and then to identify if employees are refueling too often. So in this example on the right, again, we're looking at 4 different vehicles. The first column identifies the fuel capacity for each of the vehicles. So for the first unit, Unit A, the expected number of refueling trips for this particular month was 2.8, but the actual number of trips was 4.6. So an action item, which is in the red font to reduce fueling trips from 4.6 to 3, is to make sure that refueling gallons are increased to greater than 20. And then the vehicle D is kind of an extreme example. The fuel tank capacity is 28. They were only expected to refuel one time a month, but their actual trips were 5.2. So again, this vehicle needs to be investigated to determine why it's being refueled so frequently. Next slide. FMIS is important to track gallons per mile driven to identify potential issues, mechanical issues such as faulty engine component, low tire pressure, improper alignment, etc., and then to monitor driving habits. In the example on the right, this is a Ford F-150. During the first 8 months of the fiscal year, the gallons per mile was tracking consistently, and then it started to spike in September and then continued to rise over the last quarter of the year. So again, this vehicle needs to be investigated to determine why the gallons per mile started to increase or spike in September. Next slide. FMIS data is important to track and reduce idle time, to identify excessive idling and specific routes with high idling and overall fleet idling trends. In the example on the right, this represents a group of employees that are performing the same function. Vehicles A, B, and C are achieving in the range of 2.9 to 3.5 average idle minutes per stop, whereas vehicle D is on the outer range of 4.6. So again, this is for a 1 year period. Vehicle D needs to be looked at, investigated to determine why it's not tracking with the other vehicles. Next slide. FMIS is important again to reduce idle time. This example KPI, the performance measure is to reduce the entire fleet's average idle time per mile traveled by 20%. In the description column, again, this is a 1 year KPI for the period January through December. And the goal is to reduce the average idle time per mile from 2.5 minutes to 2 minutes. Identified in this description column is the purpose of the KPI, and that is to reduce engine wear, fuel consumption, and harmful emissions. Again, the last two columns identify the KPI target. And at the end of the year, this organization did not achieve the target of 20%. It only achieved a reduction of 10% in the average idle time per mile traveled. Okay, here's another example KPI of tracking fuel fill-up duration. This is important to help identify potential issues with the fueling system, like leaks, malfunctions, etc. The performance measure is to ensure that each dispenser achieves a fill rate of 8 to 10 gallons per minute. And in the middle section, it talks about what happens when the fill rate is less than 8 GPMs. The drivers have to wait around for longer periods of time to refuel their units, so that impacts productivity. And then a fill rate of more than 10 can increase the likelihood of spills. So again, this is a daily KPI. The target's 8 to 10 GPMs. And for this particular day, the KPI result was 8.7, which was within the acceptable range. Next slide. FMIS is also important to track your fuel inventory turnover rate. That's important for managing your stock levels, to determine how quickly your fuel is being used, to identify when you need to reorder fuel so that you don't run out, and then to minimize costs by avoiding unnecessary stockpiling, and then ensuring consistent fuel availability to maintain operations. So then this example KPI looks at your fuel availability, and the description is that the organization has an adequate supply of fuel to immediately fuel vehicles at least 98% of the time. I know at the City of Tulsa, we monitored fuel availability on a monthly basis and annual basis, and then we monitored by station so that we could identify any specific station that was falling below the target, and then identify action items to improve the availability for that station. So again, this is a good example of availability rate, and now I'll turn it over to Dan.
Thanks, Brian. So obviously, there's a lot of you can pull a lot of information from a fleet management information system such as AssetWorks, and you can also marry your FMIS system with external sources such as telematics systems which combine an even more powerful combination of data and allow you to do a lot of things. Particular to identifying fuel theft, you obviously want to minimize fuel theft. You want to be able to monitor your vehicles against activities, because some of those cases that Brian showed of all of a sudden MPGs falling way down could be as a result of fuel theft. And so what you can do with some of your FMIS data is to analyze your fuel card transactions, analyze the vehicle average consumptions, and see what might be a cause of that drastic drop in MPGs. As the example shows on the right, the vehicle was averaging 14 to 15 miles an hour. All of a sudden in August, it pulled up down to 9 to less than 10. Could it be mechanical? Could there be leaks? Could be something gas? Could it also be fuel theft? Absolutely. And the system tracks that can allow you to track that. Did I lose my screen? There it is. Sorry about that. Preventing unauthorized fuel usage. You can certainly use the data available to you from the FMIS to prevent unauthorized fuel. Yes?
Sorry to interrupt. It looks like we lost your screen.
That is fortunate.
Perfect.
Okay. Sorry about that. So again, preventing unauthorized fuel use, you can certainly use the data available to you from an FMIS system to take steps to prevent fuel use. Part of that is setting appropriate fuel card limits, and some of this is done external to the FMIS, unless you have integrations where you can set individual card limits on your fuel card, where you can restrict transactions by type to prevent the use of the card for purchasing anything other than fuel, or possessing anything other than fuel or light automotive products. You can restrict the vehicle based on location. When married with telematics, you can do even more advanced fraud or use prevention techniques, such as monitoring if a fuel transaction is taking place when the vehicle is actually located at a fuel location, versus having the GPS component of a telematics solution that feeds into your system alert you when a fuel transaction takes place on a vehicle, on a car, with a card assigned to a vehicle, and the vehicle is not present at a fuel station, which is clearly a sign that the card is being misused or there's something awry going on. With the wealth of data from your system, you can certainly track fuel variance, and this is what you want to do to minimize potential fuel losses. And this is when you have your own fueling stations, when you're tracking availability of fuel and gallons in the tank, what dispensed. You want to track what was dispensed against what was purchased, and ideally you'd be within 1%. If you are seeing a variance between what's flowing out versus what was put into the tank of greater than 1%, you might have issues of potentially spillage or leakage within the system. So tracking that is very important. Whether it's faulty equipment, tank leaks, or if it could be related to theft. Brian touched on the abnormal flow rates and how controlling that. Abnormally high flow rates can lead to increased spills. Using the wealth of data from your system, you can monitor all your usage to do that. You can track the time it takes to fill a tank, which, as Brian mentioned, leads to your efficiency and the amount of downtime that vehicle sits idling. In the course of a fill, it doesn't seem like a lot, but when you have hundreds of vehicles and filling hundreds of times a year, it does add up. Looking at newer, obviously, with the growth of electric vehicles into vehicles fleets. You want to be able to look at charger uptime. So this is talking about the infrastructure itself, whether the availability of your charging infrastructure, and being able to track which chargers are operational, which ones need service, which ones are, and develop maintenance schedules accordingly so that you have the best availability for your vehicles, similar as you would with your fuel pumps. So a metric for that would be, wanting to make sure that your chargers are available 98% of the time. We've all heard stories potentially of chargers sometimes struggling to meet that limit, meet that target. But it's something, at least with the data and a good tracking system, with an AssetWorks tracking system, you'll be able to make, you'll have that information to allow you to do that. Additionally, with charger availability, you can plan usage. You can use the system to manage when you're going to charge, and you can check on vehicles that have charged and have completed their charge, because you have the integrations, so that if there is a vehicle that has finished charging, but someone else needs it, which charger could be available, what vehicle can necessarily be removed or moved out and unplugged, and set to rotate your charging schedules accordingly. And you can also obviously make sure that the right vehicles are using the right kinds of chargers, and identify the unauthorized use of chargers, so that, just like with fuel theft, you don't have other parties charging other vehicles other than your own vehicles in that charging infrastructure. You can track EV charger failure rates. And this is when your sessions are interrupted or something happens in between failures. So you can check and monitor your overall charger availability, reliability. You can start to make more informed future purchasing decisions with the data you gather as to whether that particular brand of charger or the particular model of charger fits the location where it's being used, or if potentially you need to make a change either in type of charger or in provider of service for that location. Certainly scheduling off-peak, looking at when it is most cost advantageous to charge, is data that you can get from your system. You want to cycle off-peak hours. You want to take advantage of when rates are low, but you also need to mix that up with when the operational requirements of your fleet are, depending on the type of fleet and type of vehicle and the usage of that vehicle, and how it patterns with its daily operational needs and the availability of electric charging at the lowest possible rates. You can use data to determine your vehicle rotations. You can sort of know, again, as I mentioned, when to schedule what vehicles where. Sometimes some vehicles need an emergency top off. So how do you direct them to the nearest available charging location? Having that information in one place can provide you better functionality, better efficiencies for your internal fleet operation, and just how to direct drivers to, just like you would for wherever fuel is available, you can tell them, direct them where charging stations are available, which is an ongoing issue. You also, the FMIS will capture a wealth of information from its systems, from the integrations that pull into it, and so it does allow you to actually track the electrical charging duty cycle of an electric vehicle throughout the course of the day. For example, in a chart such as this, you can see that the vehicle started this day in a charging up mode, and then charging stopped, and when it starts charging again in the track. This is all directly derated. This is all data taken from a system that allows you to map vehicles' charge cycle usage. This vehicle, and here's a second example of that, where the blue is the time that it was charging, green is when it was in operation discharging, red it was idling or at its location. As it drops, it gets charged back up, and then in the course of the day, over the course of the week, you can see that it helps you determine mission availability, criticality of charging, and how often the vehicles might need to be. If you have limited infrastructure for EV charging, it'll tell you which vehicles can be spaced out for scheduled charging over the course of days or weeks. With that, I'm going to turn it over to Mike and Terry. But thank you for your attention.
Fantastic. Thanks to the Mercury team. It's a treat to go through all that information and have that consultative approach to collecting data. This next part, led by Tracy and myself, is to focus on how to bring that data into AssetWorks to be able to develop those insights and conclusions. And so a big part of that conversation is understanding hardware and software interoperability. AssetWorks has a vision for fuel and charge management strategy to provide organizations with the best fit tool or approach for the task at hand. And depending on whether we're talking about liquid fuel, gaseous fuel, EV charging, or what have you, it can mean sometimes deploying multiple solutions alongside of each other within the organization. For example, mobile fueling versus behind the fence, commercial fueling, in the case of EV charging, light duty versus heavy duty, and on-road, workplace, public charging, and more. Practice, what that means is when we're talking about these projects and really the source of the data in the field, these projects come in all shapes and sizes, whether it be for liquid fuel, gaseous fuel, certainly EV charging. There's a lot of variety and excitement there. We see these projects take on many different forms in deployment. Sometimes one of the most effective things to do, though, at least for me, I'm a visual person, is to put a graphic like this on the screen to explain the relationship between AssetWorks, Fleet Focus, and EAM, and that fleet fuel and charging hardware. Ultimately, fuel and charging devices are a type of hardware IoT, or Internet of Things device, that needs to link back to that cloud application. Focus in EAM. And so we have a couple of different solutions to bringing data into the application for both EV and liquid fuel. Of course, for liquid fuel and gaseous fuels, we have Fuel Focus with a traditional ICU control unit connected to dispensers for liquid and gaseous fuel, but also with an adaptation for EV charging as well. And then for EV charging, going back to 2019, 2020, we've offered third-party integrations with charging networks such as ChargePoint, and Connect, and Blink, and more, in which we bring charging data back in through their system, and sometimes also send data into theirs via a batch type update. But most recently, and most similar to Fuel Focus, we also have our AssetWorks CMS for EV, which provides that real-time integration back and forth to FA and AM between that application and the chargers in the field. So I just mentioned this in case there's some question or confusion. There's a lot of different ways to bring data into Fleet Focus and EAM, and sometimes that means one or several of the solutions pictured here. Of course, each of these solutions has their own trade-offs and really and characteristics and features, and Focus, maybe less familiar with some of the EV products. There's a lot to learn, and oftentimes the best thing to do is to meet with an AssetWorks team member to talk about your needs on a project-specific basis, because there is so much technology change, and also the requirements from reveal which is the best fit for some of these projects. There are also other ways of bringing data in, such as through smart apps or through file load or transaction updates via file as well. Ultimately, regardless of how you integrate, the experience from the driver perspective is fairly consistent or streamlined. In the case of EV charging, drivers still pull up to a charger, indicate with a fleet card, ICU, of course, that can be very configurable based on what type of card readers and what type of information you wish to collect at the time of fueling, but a very streamlined process from the driver side. I also like to point out that integration is not limited to standard fuel or charging infrastructure. Integration data from fueling can be brought in whether the dispenser is in the ground under a fuel island or part of a mobile fueler, or in the case of EV, whether it's connected to the grid or conversely to a solar microgrid system, to a trailer, to a genset. All of these solutions can be integrated and brought back into FA and EAM. Regardless of the method of integration, we bring in all of the charging data and fueling data that's collected via the dispenser and the charger. At a high level, that means things like timestamp of the session, duration, fuel quantity, validation, information, and we bring that into all of your existing out-of-the-box reports. Regardless of whether it is an old or conventional fuel, like gasoline or diesel, or if it's something newer like EV charging. The intent is to not create reports for the sake of creating reports. That data is brought into your existing out-of-the-box reports. And the advantage to bringing that in, of course, to FA and EAM is that once the data is received, you're able to do the types of things which Mercury just showed previously, which is to analyze and segment that data by internal department, asset class, location, and more. For all the reasons that the Mercury team went over, there's no need to duplicate that except to say for the benefit of efficiency initiatives, loss prevention, fuel and inventory data, understanding the potential for tank leaks, internal billing, and also fuel procurement as well. We mentioned earlier that EV is a new fuel, but it is still a fuel, so it shows up in all of the existing out-of-the-box reports, except as a new column alongside the other established fuel types. And then don't try to squint at this. There's other resources and better ways to find out, but suffice it to say that there's dozens of different reports available out of the box for each of the different types of questions the Mercury team was discussing, and also the opportunity to create customer configurable reports as well. Another type of reporting, when you really think about it, are dashboards as well. So dashboards are useful because you're able to have that snapshot and visual understanding of trends. And of course, Fuel Focus provides configurable and real-time dashboards where you can use snap engages and select and manipulate charts to see trends over time. There are also notifications as well. So notifications are also a type of reporting. Fuel Focus has a large suite of notifications for dispenser issues, uptime questions, as the Mercury team mentioned. And then for EV charging, there's actually a separate suite of dashboards as well, such as through AssetWorks. Some quick concluding thoughts, and then we'll move into the Q&A. We really like to stress the fact that there is there are few types of charging and fueling infrastructure that cannot be tied back to AssetWorks. So again, whether that's an EV charger that's in the ground or attached to a 53-foot trailer with a propane genset, or if it's a mobile fueler or something else that you think of as well, it can probably be brought back into AssetWorks for review and analysis. And certainly that is also true for the different types of fuels and electricity sources as well. There's also a lot to say, too much to say on this call about pricing. Certainly liquid and gaseous fuels have complex pricing schemes and changes over time. Electricity, much more so. There is the ability to set up, of course, internal markups for electricity as a fuel, but also seasonal rates, session and idle fees, and a greater level of configuration down to the individual charger level than what is customary or what we're used to anyways for liquid and gaseous fuel. Another closing thought is that all of these integrations take time and effort to set up validations. And so it is always good to start those discovery processes early if you're an organization which currently isn't yet fully integrated, by understanding, for example, what hardware may be approved and preferred for use, and then understanding what that timeline is to get set up and have that data flowing into your production. Hopefully that you're already using as in your practice. So with that being said, I'll hand back over to Grace, and perhaps we can begin the Q&A.
Okay, everyone, we are now going to open up the floor for some questions. Just one final reminder, if you have any questions at this time, please send them to host using the WebEx chat tool on your screen. Provided we have enough time, I'll pass your question to our presenters and they'll be happy to give you an answer. Looks like we have a couple questions coming in. The first one was when Dan and Brian were presenting. So is if Vita root data is not inputted to FA, do you pull data from Vita root / Insight 360? If that makes sense.
And Tracy maybe want to address that too.
Yeah, absolutely. If they want me to take that one, I can. So the Vita communicates to field focus, and we pull that data into FA or EAM from communication there. And if I believe I understand the question from James, is that he's wanting to know if you do not have a field focus system, if you can still pull that data in. Currently, not right now, but with the API, it is a possibility that you could allow for that if the 360 will allow for the communication with an API to pull it over. Does that help answer that question?
I'll let you know if we have any.
That's fine.
Next question. The solution slide showed multiple ways of bringing fuel and charging data into fuel focus. What are the trade-offs again?
And Grace, could you repeat that one more time? That was about the different solutions.
Yeah, so the solution slide you showed showed multiple ways of bringing fuel and charging data into fuel focus. What are the trade-offs?
So there's a couple of high-level differences between these. One is the rate at which transactions are updated. So third-party integrations are oftentimes, not always, but oftentimes done as batch updates multiple times during. And that is different, for instance, than Fuel Focus or CMS, which are near real time. As a transaction ends, that posts into the system. As a vehicle is added, that is authorized for use by those systems. Those changes happen in real time. The other difference is configuration and setup. So using AssetWorks CMS as an example compared to the EV integrations, AssetWorks CMS is something which is set up in usually like a 20 or 30 minute meeting really, and the third-party integrations actually take a couple of sessions to get fully set up and configured in FA or EAM, because those systems aren't always designed for use with a fleet software, right? So there's two things there. One is the timeliness of how the data is updated, and then two, especially from a fleet management or analyst or coordinator type position, is the level of effort to maintain that integration, add vehicles, set up new chargers, set up new infrastructure, different level of effort for each.
Great, thank you. Next question, are there any guides on approved / preferred charger and dispenser hardware?
I'll jump on that. So you'll see sometimes in our presentations and other materials, pictures or call outs for certain manufacturers. I'll mention it first on the EV side, and then Tracy may want to mention on the liquid fuel side and gaseous fuel side. What we always say, though, is to speak with your account manager or your hardware manager about these sort of things, because the technology does change so rapidly and there's just hundreds of different combinations and specs. So rather than fixate too much on whether a specific line of manufacturers is approved or supported, it's just better to come in and have that big picture conversation about your project and requirements. That being said, we work with most of the major manufacturers. It's a pretty fragmented market out there. So we can't say everyone because it's just too fragmented right now, but like ABB and ChargePoint and LG Electronics and Lite-On and Blink, iHomes, Rova, quite a few, but always good to check first.
And then next, are mobile fueling ICUs set up any differently in FA?
I'll take that one. No, they're set up the same way. The only difference is that when we set them up, we're actually going to designate whether it is a fixed ICU or a mobile ICU. So you're still going to set up the site, the location, you're going to attach your pumps to the tank, and you're going to assign your IP addresses that communicate back and forth to it. So it is set up the same. It's just treated as a mobile ICU, not a fixed.
Okay, thanks, Tracy. That looks like all the time we have for questions today. If you asked a question we were unable to get to, our team will reach out to you after today's webinar. I'd like to thank you all again for attending today's presentation. I hope you all secured some valuable takeaways to keep in mind moving forward. I'd also like to thank all our presenters again once again for sharing their expertise with everyone today. I hope you all have a great day, and we look forward to sharing some more info with you next time.